Okay, we're going to try to wrap this up in this third video. I'll give you a couple more examples of translations in two directions, and then finally we will write equations of translations. This is a summary of what we've learned so far. If you have your parent function, the translations will change the amplitude if you change a. And so instead of going up to 1 or down to -1, it can go higher or lower if you change the a value. And using the period 2 pi over b, the b value is the number in front of parentheses. If the b value has been distributed, you have to factor it back out so that you have x alone at the beginning of the parentheses. So then h is your horizontal translation and k is your vertical translation. So here we have some examples. So we're starting with the function y equals sine 2, parentheses x minus pi thirds minus 3 pi halves. So first we're going to calculate the period to the function, which we know is 2 pi over b, and in this case b is 2. So the period to the function is pi. So that means we will complete one entire cycle in the interval from 0 to pi. But then we have translations, so that changes things. All right, so we're going to calculate, first of all, where all of our x values will be. So we have x minus pi thirds. That should be equal to 0 to start with. And our second important point would be x minus pi thirds equal to pi halves. And x minus pi thirds equal to pi. X minus pi thirds equal to 3 pi halves. And finally, x minus pi thirds equal to 2 pi. So we will calculate each of these. Okay, so our first x value is going to go at x equals pi thirds. Next we have to add pi thirds to pi halves. So pi halves plus pi thirds would give us 5 pi sixths, and pi plus a third is pi and a third, or 4 pi thirds. 3 pi halves plus pi thirds, using a common denominator, that's going to give us 9 sixths plus 2 sixths. That'll be 11 pi sixths. 11 pi sixths. And then 2 pi plus pi thirds gives us 6, 7 pi thirds. Okay, so this will give us one cycle. We're actually going to graph in the entire interval from 0 to 2 pi. We also notice we have a translation that goes down 3 halves. So I'll draw the x-axis high enough so I have room to go down that far. So we're actually going to start at 0 eventually. This is 1, this is 2. We have an equilibrium line at -3 halves. So we're going up and down around this line. And we're going up 1 full unit and down 1 full unit. So we notice that our first point is at pi thirds. Now we have to count across here. Since our units are basically going in thirds and sixths, let's count by that. So this is 1 sixth, 1 third, 1 sixth, 2 sixths, 3 sixths is a half, 4 sixths, 5 sixths, 6 sixths is pi. 1, 2, 3, that's 3 pi halves. 1, 2, 3, there's 2 pi. Okay, so this is 1 sixth, this is 1 third. So we're starting at 1 third. It's a sine curve, so we're at equilibrium at 1 third. Okay, so 1 third, 2 thirds, 3 thirds. No, 1 sixth, 2 sixths, 3 sixths, 4 sixths, 5 sixths. At 5, 6, we will be at a maximum of 1 unit above equilibrium, so that gives us a negative a half. At 4/3, if this is 6, 1, and this is 1/6, 2/6 is 1/3, so 1 and 1/3. We're over here at our second mark, back to equilibrium. 11 pi 6 is 1/6 short of 2 pi. And at this point, we're at a minimum value, so we're at negative 2.5 right there. And then we will be going back towards 2 pi, but 7 pi thirds is beyond 2 pi, so we don't have to go quite that far. So our graph is coming like this, going back up, and we'll stop here. Kind of went a little bit sharp. Coming back up, and we stop when we get to 2 pi, even though we haven't reached 7 pi thirds. This one's coming back this way, and it's going to be going downward, and I don't believe, no, we won't have enough to get to our absolute minimum value, so we're continuing downward when we get to 0. So this is the only part of the curve that we can see in the interval from 0 to 2 pi. And because of the length of time here, I'm not going to do the second example, but in the second example, you should notice that the 2 makes the amplitude 2 units, so you're not going to just go up and down 1 unit from equilibrium, but you'll go 2 units.